Good day, learners. Welcome back to our class. Today's class is going to be based on the ideal gas equation in chemistry. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. For our usual member, thank you for believing in us, and don't forget to like and leave a comment as we move on in this class. I remain your tutor, Latif Ismaila Akambi, your mathematics and chemistry tutor. So let's dive in. The ideal gas equation is one of the equations that is very common in the gas law sphere. But this ideal gas equation depends, or it is formed from three major gas laws, which are the Boyle's law, the Charles law, and the Avogadro's law. You can check the link below to go through the lessons of the Boyle's Charles and the Avogadro's law, including Gay-Lussac's law of combining volume. Now, what does Boyle's law state? As we know, that Boyle's law states that at a constant temperature, the volume of a given mass of gas is inversely proportional to the pressure. That is, volume is inversely proportional to pressure, 1 over P. At this point, our mass of the gas, temperature remains constant. All these are constants. So this is Boyle's law. While the second one is Charles' law that states that at a constant pressure, the volume of a given mass of gas is directly proportional to the temperature. That is, volume is directly proportional to the temperature. At this point, the mass and the pressure are constants. This is Charles' law. Fine. While the last one is our Avogadro's law. This Avogadro's law depends on the number of molecules. That is, the volume of the gas is directly proportional to the Avogadro's constants. That is, volume is directly proportional to the Avogadro's constants. At this point, the mass, the pressure, the temperature are all constants at Avogadro's law. Now, since we know that this Avogadro's constant is also directly proportional to the number of amounts, that's the amount of mole, that is N is proportionality to number of mole. So in this case, this one can be rewritten as saying V is directly proportional to N. Now, we can now combine these three together. If you look at this is volume, all true. So volume, proportionality to the first one, 1 over P, multiplied by the second one, temperature. The third one is number of mole. So volume is proportional to, when you multiply we have Cn over P. If you could recall, when we are dealing with Boyle's law, Charles' law, this proportionality has to change and leave a constant. So in this case, we can now say V is equals to, when you remove this proportionality, we put a constant R T N over P. So from here, when you cross multiply, we have PV is equals to nRT. So this equation is the equation we call ideal gas equation. It's an ideal gas what? Equation. So we're now going to look at the units of each of these elements, each of these parameters that make up this ideal gas what? Equation. We want to look at the values and units of the gas constant R. Now, when we look at this gas constant has about two different values depending on the what? Depending on the units. The first one we're going to look at is when our pressure, when our pressure is measured in atmosphere, that is ATM, is measured in atmosphere. Are we there? When the pressure is measured in atmosphere, then our volume is measured in decimeter cube. And the number of mole. So at STP, standard temperature and pressure, are you there? Our volume is going to be 22.4 decimeter cube. That is under the standard temperature and what? And pressure. And we want to now look at our unit of R. PV is equals to nRT. When you divide both sides by NT, to make our R the subject of the formula, our R becomes PV over what? NT. So we now put our values here. We put our values here. Our pressure is in the atmosphere, that is 1 atmosphere, 1 ATM, multiplied by our volume, 22.4 in decimeter cube, divided by number of mole, that is 1, and number of amounts, that is 1 in mole, multiplied by our temperature, our standard temperature, that is 273 in Kelvin. So let us take our calculator to multiply and we divide. So in this case, we have 0.08205. So now this is atmosphere, dm cube. So this is divided by mole. It gives per mole. Then divided by Kelvin per Kelvin. So approximately 0.0821 atmosphere dm cube per mole per Kelvin. So this is the unit of gas constant. When our pressure is in atmosphere, our volume is in what? Decimeter cube. So we have it to be 0.0821 atmosphere dm cube per mole per Kelvin. Let us now look at the second case of it. For the second case, this is when our pressure is in Newton per meter square. Newton per meter square. Then our volume will be in meter cube. But Newton per meter square, or when the volume is in meter cube, we have to upgrade it to have a higher values. Let our pressure be in kilonewton per meter square. Then our volume now will now be in decimeter cube. It will be in decimeter cube. So formula R is equals to PV over NT. This our pressure in kilonewton, it has a value of 101.3. So the unit here is kilonewton per meter square, multiplied by our volume, that is 22.4 in decimeter cube, divided by 1 mole, multiplied by temperature, 273 Kelvin. Let's take our calculator now. Let us multiply this and divide it by 273. So the value given to us now, we have 8.3118. So we have kilonewton per meter square dm cube per mole per Kelvin. So approximately we have 8.312. Now, in our physics, in our derived unit in physics, kilonewton per meter square dm cube, all these one give us joule. Then per mole per Kelvin. So the shorting unit of our gas constants is in when our pressure is in kilonewton per meter square, we have it to be joule per mole per Kelvin. So when you see in your objective question, you see kilonewton per meter square dm³ per mole per Kelvin, you know it is actually the same thing as joule per mole per Kelvin. So these are the two values we are going to be using in doing our calculation of ideal gas equation. Now, the subtopic we're going to be looking at is the derivation from ideal gas equation. What are we deriving from ideal gas equation? We know very well that PV is equal to nRT. Our pressure is directly proportional to amount of the gas, the number of amounts of the gas. So which means that when the pressure increases, the amount of the gas will also increase. Increase in pressure will lead to the increase in the number of the amount of the what? Of the gas. From here, let us say P is equals to Kn. K is equals to P over what? Over N. We can increase this one by saying P1 over N1 is equals to P2 over what? N2. From here, when we cross multiply, we are going to have P1 N2 is equals to what? P2 N1. Or finally, we have P1 over P2 is equals to N1 over N2. When you cross multiply, you are going back to this place. So you can have a derivation from here. So this one can be used to solve questions, many questions. Our pressure, our volume here is also directly proportional to N. V is equals to Kn, since our K is constant. V1 K will equals to V over N. So we have V1 over N1 is equals to V2 over N2. Cross multiply as usual. V1 N2 is equals to what? V2 N1. Also, we can say V1 over V2 is equals to what? Is equals to N1 over N2. Similar to this. The third one, PV, will also be directly proportional to our temperature. In this case, our N is constant. N is constant in this place. So PV now is equals to KT. Since K is constant, make it the sort of the formula. So we have PV over what? T. From here, you can modify this one to what? P1 V1 over what? T1 equals to what? P2 V2 over what? T2. If you could recall, this is actually the general gas equation. Finally, on the derivation from this ideal gas equation, from our figure 4, PV is equals to nRT. If you could recall, our N from our stoichiometry, N is equals to mass over what? Molar mass. If you could recall. So from here, PV will now equals to mass over molar mass, then RT. Now, that is mass over molar mass. Also, from our physics, density, let me write this in well. Density is equals to mass per unit volume. So density equals to mass over volume. Mass is now equals to density multiplied by volume. So anywhere I see mass in this case, I'm going to put what? Density times volume. My PV is equals to, my mass now is density times volume over molar mass multiplied by what? RT. This is like over 1 as well. So volume cancel volume. So P is equals to density RT over molar mass. So this is another fourth derivation that we can derive from our ideal gas equation. If you find this class interesting, and you've not subscribed to my channel, kindly do so and click the notification bell for my subsequent contents. And don't forget to share, like, and leave a love emoji as you leave the channel. Thank you very much as we look forward to the calculation involving ideal gas equation.